We've shown that drainage and utility feature definitions are different than typical feature definitions in that they have SUDA and hydraulic model properties. Another thing to keep in mind when modifying a feature definition for drainage and utilities is that when a drainage and utility model is created, it creates two models. It creates a 2D and a 3D model. The easiest way to view both 2D and 3D models simultaneously is to right-click, clicking View Control, and to views Plan in 3D, which I've done here. In this view, I have the 2D model open. It actually has the 3D model referenced in by default. If I open up my references, I can toggle that on or off. You can see the 2D and the 3D model referenced in. The key thing to take away from this is when modifying a drainage or utility feature definition, if I'm viewing the 2D model, I must click the 2D model itself to modify the feature definition. Now that I've selected the 2D feature definition, I can go ahead and modify the ground elevation. You can see it's been modified. However, if I click the 3D model, it'll show it as a referenced file and it won't let me modify it. However, if I go back into the 3D viewport and select the 3D model, it will let me modify it. Manipulation of these 2D and 3D views can be critical to seeing issues and updating your design. For example, if we change this from illustration to transparent, we're able to see the system much better and how it interacts with the pavement as well as the ditch. A 2D view may be more appropriate to view contours and plot catchment areas for a drainage system, for example. And you can use the OpenFlows model to determine a scaled area, for example, and use it straight from the model. Or you can even use defined areas. As you can see, I've switched this to false. And as I come back to it, this should be false. If I want to put in my own delineated area, it'll update in both places. While the utility properties / hydraulic properties and feature definition properties are largely dynamic on most things, there are still plenty of things that the hydraulic properties are static on. When you first start a design, it'll import all the KDOT workspace defaults. If you modify the hydraulic library, catalogs, or prototypes after you've placed an inlet, it will not go back and update that. Unlike if an inlet is ruled to a terrain, it will update the grade elevation. Hydraulic properties are largely static and they're imported and can be changed, but it doesn't apply to anything placed before those changes. For example, if I wanted to say change the Manning's N for all inlets from 0.016 to 0.015, I could access the prototypes and change the ditch inlet type to 0.015. However, it won't change this inlet as it was already placed previously. If you need to modify inlets on a global scale after they've been placed, it'll need to be done individually or through flex tables, and that'll be covered on a later video. In summary, the hydraulic and utility properties are typically dynamic with the general feature definition properties. As far as physical characteristics such as a grade elevation or an invert, just keep in mind that many of the hydraulic properties may not necessarily translate, and so these should be reviewed on a case-by-case basis.